Day 9,
Hello
Car
and
Audio
welcome
School.
to day 9. This is your car audio school where we teach you how to do the install yourself, learn how to become a technician, to get a job at a shop, and or start your own business, which is what I plan to do. This is for entertainment and educational purposes only, and this is my online resume to show people I know what I'm talking about. And our main goal here is to keep you at shops and teach you how to do it yourself. With that being said, today we're going to talk about fuses and protection circuits, or circuit protection. So we'll get right into it. Fuses and circuit breakers are like safety switches for electricity. They're designed to stop the flow of electricity if there's a problem, protecting your car and equipment. Second, we'll call it the sacrificial lamb because that's what they are. A fuse is a thin wire that's designed to melt and break the circuit if there's too much electricity flowing through it. Think of it as a sacrificial lamb. It sacrifices itself to save the rest of the system. So it's kind of like a protect mode. Another analogy, the resettable switch. A circuit breaker is like a reusable switch. It trips or turns off when there's an overload, but you can usually reset it and turn it back on once the problem is fixed. So for that example, let's say circuit breakers in your home. When you have too many appliances on one circuit or wall socket, so let's say space heater, refrigerator, a washer and dryer. This is totally overload. And a heating blanket. Under normal circumstances, maybe the washer and dryer will work at the same time, but not the fridge, or the fridge by itself and the heating blanket. Definitely the space heater has a lot of draw. It's power hungry, so it wants a lot of current. It wants a lot of flow of power. But if you turn all of these things on at the same time, they all have their draw. So let's say the gauge of wire is rated at, we'll call it 1,000 watts. And the washer and dryer by itself take up 300, so there's 600 all by itself. The space heater takes up another 400 all by itself. The refrigerator has points of power surges, so when it's resting, we'll call it the RMS. We'll give that another 300. When it's resting, we'll call that 150. And when it kicks on to cool off everything, it jumps or surges up to, we'll call it 300. You're demanding 500 watts or so of current to be facilitated or pushed through the conduit or that wire at one time, which will overload that wire and make it hot. In most cases, making that wire the fuse, and then your house is on fire. This is where circuit breakers come in, or fuses, and they are a thinner wire designed to be broken or disconnected when that large flow of current, we'll call it electrical water right now, just to have the visual. When that large current, like a tsunami or tidal wave, flows through that conduit or that wire, it creates resistance because you have this big surge flowing down this very tiny, and I won't say tiny, but in comparison, tiny electrical wiring, and that flow going through it is creating resistance on that wire, resistance, hands rubbing together through that wire, making it hot. Resistance creates heat. If you have a regular fuse, it will break that connection and break the circuit to that one lane highway or single connection, and everything in that circuit will turn off or will stop, will not continue to flow electricity through it. And that's what it's designed for. In the case of a circuit breaker, which I have seen people put on vehicles, more so use cases in marine sound systems. They'll have a circuit breaker, and they do use fuses there, but I have seen circuit breakers there too, where everything will shut off and the circuit breaker, the switch, will kick up or disconnect the flow of electricity and stop electricity from its path of return. This case at least gives you the opportunity to figure out what the issue is and turn it back on and continue the flow. And if it goes over the amperage of that fuse, it'll kick off again, whereas a regular fuse will break and it is a one-time use and you'll have to put a brand new fuse in there. 7 minutes, let's see what we can do. So I'll come over here to my other notes, and I'm probably going to have to make this a two-part, or leave it at that and put it in the paid content. I know I'm trying to hurry up. Imagine electricity flowing through wires in your car like flowing water through pipes. This flow of electrical water is called current and is measured in amps or amperes. Voltage is like pressure, and that is the pushing of that water. Now imagine what happens if there's a problem in the pipes. What if two pipes that shouldn't connect suddenly do? Power and ground. That's called a short in your car's electrical system. A short is when electricity unexpectedly finds a very easy, low resistance path to flow, like a negative and positive connection touching where they shouldn't be. This causes a huge surge of current. Think of it like a dam. A massive amount of flow rushes through. In an electrical system, uncontrolled current can overheat the wires, causing them to smoke, melt, or even start a fire. This is where the circuit protection comes in. Its job is to prevent damage, especially fires, by stopping the excessive flow of current. Two main types of circuit protection are fuses and circuit breakers. Fuses are like one-time protection protectors. Inside a fuse is a thin filament designed to overheat and melt if too much current flows through it. When it melts, it breaks the electrical connection, stopping the dangerous current. Blown fuses have done this job to protect the circuit. You can often tell if a fuse is blown by looking at it. The filament might be melted. Fuses come in different styles, shapes, and current ratings like 5 amps or 10 amps, etc., and marked with a number and sometimes a color. So they're all color-coded, they're all number-coded. They're easy to remember because they're the same across the board. They're basically universal. You can tell by the color, or you can tell by looking at it. It is crucial not to use a fuse with a higher rating than recommended, as this could lead to overheating the wires. So one thing is going to burn. Do you want it to be the fuse, or do you want it to be the wire? Because the wire can very easily become the fuse. You want it to be, you want the fuse to be able to take as little current as possible to keep the electrical connection intact without being able to take more current than the actual wire that you're using, and then the wire becomes the fuse. This is called overfusing. There are also slow blow fuses. I hate those fuses that can handle a higher current for a short period of time, but using one where regular fuses are needed can also be a form of overfusing and unsafe. In a vehicle, if in a vehicle, you'll often find multiple fuse panels, one usually near the battery and another around the dashboard. This talks about circuit breakers, but it is important to have circuit protection installed as close as possible to the power source. Power source being the battery, so that's where you're going to put the fuse within, I'll say, 12 inches of the battery. I'll show you a visual representation of what that looks like. But basically your connector going to your battery should be, I'll call it 6 to maybe 8 inches, and then fuse it, and then do your power run all the way to your amp. I have thousands of pictures to show you of vehicles that have come in, and this has been an issue. Let me see where I'm at. If you're adding multiple high current devices like amps, each should have its own circuit protection or fuse on its power wire. Also, any wire running through the metal part of the car, for example, the firewall, or sometimes you can run it through a wall in the back of the vehicle. Some people run it under the vehicle up to the battery. They should also be circuit protected, and more importantly, have a rubber grommet that, or plastic, that is in between the firewall, we'll say it like that, so you can run your cord through and it doesn't chip or cut itself on the metal wall that you drilled through, either with, should be with a unibit, or a drill bit. Those edges become really sharp, and it's very easy to hit a bump and arc the metal braiding inside of the wire on the wall, and then you have a fire. Yeah, so in simple terms, fuses and circuit breakers are safety devices that act like a breaking point in your car's electrical system. If too much electrical water tries to flow through, they will stop and prevent fires and damage to your car's electrical system. So that is fuses and circuit protection. Tomorrow we will be back with another idea or concept, and I'm learning that this is theory. So yeah, with that being said, tip your technicians, because they go through a lot to learn all these things. And most of the time they're learning on the job, which, yeah. Donate. We need tools. We need all data. We need Mixer One. We need Direct Tech to be able to show you, once we get on the computers, how everything works. And yeah, almost 15 minutes. So thank you. Bye-bye. Come again.